So you know how to name ionic compounds. The other type of compound that we're going to encounter is called a molecular compound. And we're going to learn how to write their names and formulas in this video. To start with, what a molecular compound is. Well, it's not made of ions, like ionic compounds. And because of that, that means there aren't any metals in the compound. Remember that metals always lose electrons to become stable. But that's not the only way to become stable. You can gain electrons, and you can also do something else called sharing electrons, and we'll talk about that later on. But metals, the only way metals can become stable is by losing electrons. So, and that will form ions. So because these molecular compounds don't contain ions, there are no metals in them, just nonmetals. So they're easy to identify. If you see a compound that's just nonmetals, most of the time it's going to be a molecular compound. The way we name them is a little different now, because when we have an ionic compound, we can just name the two ions in there and they'll always go together in a particular way. That's not the case when you have nonmetals. For example, if we have CuO and Cu2O, we can easily name those two, because CuO, that has to be copper plus 2, O minus 2, that has to be copper 2 oxide, and Cu2O, that means the copper has to have a plus 1 charge, and that would make it copper 1 oxide. You'll have to deconstruct those two compounds to prove that to yourself, but you should be able to know the difference between those two. But take a look at CO versus CO2. I don't have ions in carbon monoxide or carbon dioxide, so I can't refer to a carbon 1 or carbon 2 or carbon 4 or whatever. I have to have another way to name them. And so I do. I have a specific way of naming molecular compounds. The way we're going to do this is we're going to distinguish between the compounds that contain the same elements, like CO and CO2. Both contain carbon and oxygen. I can't call them both carboxide. I have to be able to distinguish between them. And so I'm going to use some Greek prefixes. I'll list them in just a minute, but you can hear the difference between carbon monoxide and carbon dioxide. That tells me that one of them has 1 oxygen and the other has 2. When you name a compound, you're going to just name what you see. You're going to specifically tell what elements and how many of them you see. You're never going to start the name of a compound with mono, even if there is one of the elements. And you're going to make sure that you elide or join together or sort of blur together when you have like vowels. And you'll get a sense of this as you practice it. The other thing is that all molecular compounds that we're going to name, all of their systematic names will end in IDE as well. So in a way, they sound like they might be ionic compounds, even though they're not. Here are the Greek prefixes you need to know, the first 10 of them. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. To be honest, the hardest one for people to remember is tetra, number 4. Everybody wants to say quad. Or quatra, or something like that. Well, that's the Latin prefix. We're doing Greek. Okay? In Greek, 4 is tetra. The other one that people like to get wrong is number 7. They like to say septa, like September, right? But that's Latin again. In Greek, it's hepta. The rest of them should be easy to remember. Mono for 1, di, tri, etc. Okay? And we use these prefixes in front of the name of the element that we're naming. Let's do some examples and you'll get a sense as to what we're talking about. So here are the ones we want to name. N2O, NO2, N2O4, and NO. All of them contain the exact same elements, nitrogen and oxygen. I can't call them all nitrogen oxide because I won't be able to tell which is which. And believe me, with these compounds here, you want to know which is which. N2O, you breathe that stuff in, you start laughing. Things get kind of funny. It's called laughing gas. NO2, you breathe that stuff in, you die. It's poisonous. N2O4, you probably wouldn't notice. NO, you breathe it in, poisonous again. So just calling it nitrogen oxide doesn't give you enough information. And with a lot of these molecular compounds, you really need the information. So we're going to use some Greek prefixes and we're going to name what we see. We'll start with N2O. What do we see there? Well, we see 2 nitrogens and 1 oxygen. So we're going to name it. The prefix for 2, the Greek prefix, is di. Dinitrogen. The prefix for one oxygen, is mono. Now, we don't want to say monooxide. That's hard to say. It doesn't sort of flow off the tongue. So we just say monoxide. So N2O, dinitrogen monoxide. If you've heard laughing gas called nitrous oxide, that's its common name. These are called systematic names. They follow a series of rules. NO2, poisonous gas. It's sort of a brownish colored gas. It's very poisonous. You don't want to be breathing in it at all if you can avoid it. What do we see? We see one nitrogen. The prefix for one is mono. But remember, we never start a name with mono. So we just say nitrogen. Two oxygens, dioxide. Nitrogen dioxide. N2O4. Well, now we got two things going on. So we have two nitrogens, just like we had in A. We have two nitrogens. So the first word is going to be dinitrogen. And now we have four oxygens. The prefix for four, the Greek prefix, is tetra. Tetraoxide. We have to stutter a little bit to say it that way. So we just elide the vowels. We blur them together. We get tetroxide. Dinitrogen tetroxide. And this last one, NO, one nitrogen, one oxygen. One is mono, but we don't start with mono, so we just say nitrogen monoxide. Those are four different names for four different compounds, but they all contain the same exact elements. But now, by using these prefixes, we have an easy way to tell them apart. Okay, I want you to try these. Stop the video, make sure you have your list of Greek prefixes, and try to name these four compounds. SO2 and SO3, they're very similar. P4O10 and ClO2. That's not an I, that's an L. ClO2. Go ahead and stop the video and try to name them. Are you ready? Let's see how you did. So in A, we have one sulfur and two oxygens. We don't start the word with mono, so we just say sulfur dioxide. In B, we have one sulfur and three oxygens, so we say sulfur trioxide. P4O10 has four phosphoruses, tetraphosphorus, and 10 oxygens, decoxide. Deca is prefix for 10, but the decaoxide, the A goes away, decoxide. ClO2, one chlorine and two oxygens, but we don't start with mono, so chlorine dioxide. Pretty simple. You just write what you see in the formula. To go the other way, you just write down the formula based on what the name tells you to write. The name tells you what elements and how many there are in the formula. It's pretty easy. Now, there are some exceptions. There are some compounds that are so common and have names that are so old that we use their old names, their non-systematic names. Look at these four. Okay? If we were to name them according to the rules, NH3 would be called nitrogen trihydride, but it isn't. It's called ammonia. If we were to name H2O by its systematic name, we'd have to call it dihydrogen monoxide. I'm going to tell you something about dihydrogen monoxide in class. Pretty cool. But we don't call it that. We call it water. It's its old name. H2O2 should be, according to the rules, dihydrogen dioxide. But that's not what it's called. It's called hydrogen peroxide. It's its common name. And finally, CH4 should be carbon tetrahydride, but it's called methane. These four you just have to know. You're going to see them a lot. They're very common in chemical reactions, and they're very, very common compounds in general. So you've got to know their names when you see them, because we don't use their systematic names anymore. Okay? Pretty simple. Takes a little bit of practice, but once you get those Greek prefixes down, watch out for numbers 4 and 7, tetra and hepta. But once you get those down, it should be pretty easy.